Hello guys, welcome to Ramta Solutions and welcome to your grade 12 mathematics Euclidean geometry exam prep. Today we are going to focus on the Northwest Province's September 2024 math exam. So because this is a past exam paper, it's important that we read instructions. But please note, I'm not going to read all of them. However, all the instructions are important. So I will begin. Instruction 2, answer all the questions in the special answer book provided. We don't have that, so we will skip it. Instruction 3, clearly show all calculations, diagrams, graphs, etc., which you have used in determining your answers. Instruction 4, answers only will not necessarily be awarded full marks. So it's important, it's linked to instruction 3. And then instruction 6, should you happen to find values of certain lengths, instruction 6 says, if necessary, round off answers correct to 2 decimal places unless stated otherwise. Instruction 7, diagrams are not necessarily drawn to scale. So don't try to measure a length to get its approximate size, okay? Instruction 9, in as much as you are working for distinctions and all that, it's important that you improve your handwriting, that it may be a good presentation. So write neatly and legibly. I know a lot of us, we struggle with this one. When we see this instruction, you're like, but of course, we have to keep working on this, guys, okay? We have to improve our handwritings, okay? All right, let's go now. Normally Euclidean geometry is question 7, 8, 8 sometimes, but let's see. Here it's question 8. As you can see, there's an instruction. Give reasons for your statements in questions 8, 9, and 10. Let's go now. Remember, if you are using a mobile device, please rotate your screen. All right, let's see now. DE is the diameter of the circle having center O. Okay. Points A and D. Points A, B, and C. Points A, B, and C lie on the circle. All right. AC is parallel to DE. Where is it? AC is parallel to DE. Okay, cool. AF is equal to FC. Okay, I can see them. Angle ODC is equal to X. All right. Angle ODC is equal to X. Where is it? I see it here. All right. 8.1. Remember, guys, this question is 10 marks. So we must be done in 10 minutes. In other words, in the 13th minute of this video or the 12th minute of this video, we must be done with question 8. 8.1, calculate the size of F2. F2, we can see that it is a line from center, but interestingly, it is bisecting the chord AC. Please do not say perpendicular from center. Okay, so they said the size is 90 degrees. It was not given, so please do not say perpendicular from center. Okay, so you can say this is line from center to midpoint of a chord. Okay, to midpoint of a chord. It's okay like this. Okay, to midpoint of a chord, it's okay like this. All right, cool. Now let's go to 8.2. It says determine in terms of X, giving reasons, the sizes of the following angles. Angle O2. Interestingly, angle O2, I will begin by saying angle C1 is equal to angle D. Why? These are angles opposite equal sides. Why? Because we are saying because we are saying angle OC rather is equal to OD. Why? These are the radii of the circle, so they are equal. All right. Therefore, we can say 2C1 plus angle O2 is equal to 180 degrees. What's the reason? Sum of interior angles of a triangle. Right? So sum of angles of a triangle. So we know that angle C1 is x. Therefore, this means angle O2 is 180 degrees minus 2x. And then we died. Right. This is 8.2.1. Now, 8.2.2, determine in terms of x the value of b. The value of b in terms of x. So the value of b in terms of x. It'll be very interesting. Okay, it will be very interesting. Very, very interesting. Okay, but no worries. We will attempt this question regardless. So let's see what we have here. So what we have here, for effect, we can say angle AFB will be 90 degrees, but does it really help us? That's the question that we should ask. Does it really help us? Not really. It is not helping us. And maybe it does. Maybe it does. So we can say, check this out. I will say angle, we know angle O1. So we do not know angle O1. We could have used angle at the center twice angle in the circumference, right? But we can find angle O1, isn't it? We can find angle O1. So I will say, first thing first, let me find angle AFB. Angle AFB is equal to F2, which is 90 degrees. What's the reason? These are vertically opposite angles, all right? These are vertically opposite angles, right? These are vertically opposite angles, right? Good. And then, all right, that's something that we should know, isn't it? That's something that we should know. So, another thing that we ought to know is this. In order for us to be able to find angle A, we need to find angle O1. So let's find angle O1. So angle O1, is it possible to find angle O1? Let's start there. Angle O1, is it possible to find him? As for me, I am not sure. But one thing I can tell you is this. I will tell you now. I will say to you, angle O1 plus angle O2, okay, plus angle F2 is equal to 180 degrees. Why? These are co-interior angles. Why? Because AC is parallel to DE. Right? AC is parallel to DE. Okay? For now, I do not know what O1 is, right? But I know angle O2 is 180 degrees minus 2x. And then I also know that F2 is 90 degrees, isn't it? So I can confidently say angle O1 is, what is it? It is 2x minus 90 degrees. That is angle O1. Okay. Proceeding, angle O1 is 3x minus 90 degrees. Now, angle A is equal to, I want you guys to see this, angle O1 is twice angle A. So this will then be x minus 45 degrees. What's the reason? Angle at center is twice angle at circumference. Is twice angle at circumference. Hence, angle A is equal to x minus 45 degrees. Okay, having said that, I already found angle AFB. I have angle A, therefore I can find angle B. Angle B plus x minus 45 degrees plus 90 degrees is equal to 180 degrees. Why? This is sum of angles of a triangle. So this is sum of angles of a triangle. So what is angle B? Angle B in terms of x, let's get our 6 marks. In terms of x, it is 90 plus 45. It's 135. So it's 135 degrees minus x. And that is our angle B. Okay, that is our angle B. 6 marks in the back. So right now we have 10 marks. Okay, we have 10 marks. Okay, we're able to finish this in less than 10 minutes. So let's go. Now, let's go to question 9. So we now go to question 9. Okay, we are now headed to question 9. So question 9, 9.1 says, in the diagram is triangle ABC with DE parallel to BC. Now prove the theorem that states that AB over DE is equal to AE over EC. This is that theorem that we call proportionality theorem. Okay, so I can't copy this, so let me just draw it. So this is what we have: A, D, E, and then B, C. DE is parallel to BC. Okay, cool. So what we need a construction. Okay, we need a construction. Now in the construction, I will say draw. So this is a solution that you have in your textbooks, guys. I will say draw H1 to perpendicular to AD. Okay, then draw what? Draw H2 perpendicular to AE. Then I'm gonna say draw BE and CD. Draw BE and CD. Okay, draw BE and CD. So I'm gonna change the colors now because I need to draw. Let me use a red one. So let's say here is your perpendicular, and then here again it's your perpendicular. I'm gonna show. They said draw BE. So here you are, BE. And then they also said draw DC. Okay. So just to make sure. Okay, so perpendicular. Okay, perpendicular. I'm gonna call this one. It's called H1, and this one is called H2. Okay. It's called H2. Now let me go back to my font size. Right, having done that, this is what you need to do. In your answer sheet, guys, this is what you need to do. This triangle, this one here, will be given. You just need to add these lines, okay? Perfect. So I will say, now I will take area of triangle ADE over area of triangle BDE. Let's see. This is half. We know half times base times height. So the base here is perpendicular to the height. What is the base for ADE? It is AD. What is the height? Height is H sub 1. Again, for BDE, these two triangles, ADE and BDE, they share a vertex. So they have same height, H1. So therefore, it means here it will be BD or DB. Okay, it will be DB. It will be DB times H sub 1. Right. So as you can see, the halves are cancelling, and so are the h1s. So AD, it'll be AD over DB. Okay, now we then look at area of triangle ADE again over area of triangle CDE. CDE. Let me just say CDE just to go back. As you can see, the height is h2, it's perpendicular. So these two triangles, they share this vertex D, so they have the same height. Their bases are AE and EC. Let's go. It is half times AE times h sub 2 all over half times DB times h sub 2. As you can see, the halves and the h's are cancelling. We are left with AE over DB. Okay, so there is something that I am seeing. The triangle BDE and triangle CDE, they are all they are triangles within parallel lines. They have the same base and therefore they also have the same height. Okay, therefore that means they are equal. So let me just note it. Area of triangle DBE is equal to area of triangle CDE. Why is that? They have the same base and same height. Okay, they have the same base and same, all right? They have the same base and same height. Therefore, if that is the case, we can say this therefore means area of triangle ADE over area of triangle DBE is equal to area of triangle ADE over area of triangle CDE. Triangle CDE. Now, what was the area of triangle ADE over area of triangle BDE? It was AD over DB. Okay, cool. AD over BD, isn't it? AD over BD. Let's go. AD over BD. And then area of triangle ADE over CD. It was AE over. Hold on. What did I do? I'm supposed to say EC here. My mistake. This is supposed to be EC. This is supposed to be EC. This is supposed to be EC. Let's see. Area of triangle CDE. Here was it. CDE. CDE. It's supposed to be EC. So sorry about that. Therefore, it is EC. Right? It is EC. Then we have proved the theorem, proportionality theorem. Okay? We have proved proportionality theorem. Now, Azish, 9.2, let's see, 9.2, let's go, 9.2, let's see what it says. 9.2, it says in the diagram is triangle PQR with ST parallel, okay, ST parallel to QR. K is a point on QR and is joined to T, I see it, and P, okay, cool. PS is equal to Y, SQ is equal to Y minus 1. What else are we given? TR is equal to Y minus half, and then PT is equal to 3Y over 2 minus 3 over 4 units. All right, 9.2.1, calculate with reasons the value of y. Calculate with reasons the value of y. So what I can do, I will say, which one is easy? Okay, let me just say PS over SQ is equal to PT over TR. What's the reason? I will say prop theorem, or you can say line parallel one side of a triangle. Okay? Line parallel one side of a triangle, whichever you like. So let's see. What is PS? It is y units. SQ, it is y minus 1 unit. What is PT? It is y minus, hold on, PT, it is y3, okay. It is 3y over 2 minus 3 over 4. And then what is TR? It is y minus half. So cross multiply, we will say y times 1, y minus half equals 3 over 2y minus 3 over 4 times y minus y. So here we have y squared minus half times y. And here we will have 3 over 2 times y squared minus 3 over 2 times y minus 3 over 4 times y plus 3 over 4, isn't it? So, rather multiply throughout by 4 because I see the lowest common denominator here is 4. Let's multiply throughout by 4. We then have, remember guys, multiplying throughout by 4. We then have 4y squared. 4 times half is 2, so minus 2y equals 4 times 3 over 2 will be 2 times 3, it will be 6. So 6y squared, isn't it? And again, minus 6y. And then here, 4 times 3 over 4 will be minus 3y. Obviously, here it's still 3. All right? Good. So I will say 0 equals 6y squared minus 4y squared will be 2y squared. 6y minus 6y minus 3y is minus 9y plus 2. It will be minus 7y plus 3. Factorizing this, it will be 2y minus, leave a space, y minus, leave a space. It must be minus 1 minus 3. Right? Therefore, we can say y equals half or y equals 3. Either of them works, okay? Either of them works. So half units, which is 0.5 units, or 3 units. Each of them works. Okay? Cool. 9.2.2. 9.2.2, let's see. If angle PQT, okay, if angle PQT is equal to Q, okay, prove that PSKT, okay, is a cyclic quadrilateral. What did they say? PKT. Where's PKT? Oh, this angle here is equal to angle Q. Oh, this is interesting. I will begin it by saying, okay, first thing first, we are given that angle PKT is equal to Q. It's given, isn't it? But I know for a fact that this is, if these lines are parallel, okay, if these lines are parallel, I know for a fact that angle Q is equal to angle S. Why? These are corresponding angles because ST is parallel to QR. Therefore, angle P, what is it? Angle PKT is equal to angle S. Oh, I do see something here. They are like this. Do you guys see them? And if they are like this, I am seeing angles on same segment. Okay. Therefore, as I conclude, I will conclude by saying PSKT is a cyclic quadrilateral, but Y is a cyclic quadrilateral, but why do we say it's a cyclic quadrilateral? because of the converse of what? Of angles on same segment. Remember, I'm using converse because these were not concyclic, right? They were not lying on the circumference of a circle. So it's converse of angles on same segment. Okay, angles on same segment. Okay, angles on same segment. Okay, cool. Now, question 9 is done and dusted. Now let's head to perhaps question 10. Let's head to, are we done with it? Yes, we are now heading to question 10. Okay. Okay, question 10. So let's see. Question 10. So how long are we supposed to be doing this? 12 marks. So 12 and 10, 22 minutes. We are a bit slow. Question 10, let's see. 10.1. Let's see. In the diagram, D is the nice. In the diagram, D is the center of the circle. BF, I see it. BF is the tangent that touches the circle at B. I like that. C lies on the circle to form chords AC and CBC. D is joined with F, and BE is equal to DE. Cool. 10.1.1. Prove that angle C, where is it? Prove that angle C is equal to angle ABF. All right, cool. So angle ABF is equal to 90 degrees. What's the reason? The reason is tangent is perpendicular to diameter, isn't it? Tangent is perpendicular to diameter. Remember, D was the center. Again, we also know that angle C is equal to 90 degrees. Angle at the center is twice angle at the circumference. Otherwise, for this one, since it's a diameter, we like using angle in semicircle. Okay, we like using angle in semicircle. Okay. Now, as you can see, angle ABF is equal to angle C. Right? Happy? Great stuff. 10.1.2, prove that DF times BC is equal to AB over BD. For this one, guys, hear me out. For this one, it's important that when you do that, you first prove the similarity of the triangles. So it seems like we will have to prove, I see a DF, I see a BC, I see an AB. So we'll have to prove the similarity of these two triangles, ABC, and another one I will define later. So, what did we say? So we did say that angle C is equal to angle ABF, isn't it? Angle C is equal to angle ABF. This we proved in 10.1.1, isn't it? Good. Now, proceeding, we can see that angle D, in fact, let me take angle B, because let me take angle B. So I'll say angle B2 is equal to, hear me out, angle B2 is equal to angle D2, right? Is equal to angle D2. What is that? Is equal to angle D2. Why? Because these are angles opposite equal sides, right? For it is given that BE is equal to DE. Good. Now, what are we left with? We are left with angle A is equal to angle F. This we can get by virtue of saying sum of angles of a triangle. Okay. Therefore, I will say triangle, I want to say ABC. Triangle ABC is similar to angle A is equal to F, angle B is equal to D, angle C is equal to angle B. right? So FDB. What's the reason? We use that corresponding angles are equal. So as you can see, we have DF, FC, AB, blah blah. So let's begin with um BC. So I will say BC corresponds with what? BC corresponds with, as you can see, corresponds with DB. Okay, corresponds with DB. And then I also see AB. So AB is from this triangle ABC. AB corresponds with DF. Okay, corresponds with DF. Why do we say this? Because we said triangle ABC is similar to triangle FDB. Okay, cross multiplying throughout, we will have DF times BC equals AB times DB. Happy? And this is how we do it. Right. Great stuff. Now, this is very interesting. They say we must prove that E is the midpoint of the circle that passes through the points D, B, and F. I like this one. I like it. For 4 marks, I looked at it and I'm like, 4 marks. As you see, but it's okay. Let's have to it. So, we are told that, one BE is equal to DE. All right, it is given. All right. So hold on. They say we must prove that this guy is a midpoint. All right. They say you must prove that this guy is a midpoint. The circle is passing through. The circle is passing through what? The circle is passing through DBF. If the circle is passing through DBF, wow, it means the circumference of the circle. If A is a midpoint and the point DE is equal to, hear me out, DE is equal to BE. Wow. Then we must be saying, therefore, angle E is the center. Okay. Therefore, E is the center. Okay. E is the center of circle DBF. Why? Because BE and DE are equidistant to the circumference. All right, are equidistant to the circumference, isn't it? If they are equidistant to the circumference, E must really be the center. Therefore, E is the midpoint. Okay, so E is the midpoint. Okay, is the midpoint of the circle. Remember, a fancy way now is midpoint of the circle, center of the circle. Okay, it's the same thing. I, for one, when I looked at it, I'm like, I'm doing it like this. No maganja. All right, guys. Now, 10.2. 10.2, I know, guys, when you look at this, you're like, you're now. 10.2, let's see. 10.2 is very interesting, in fact. 10.2 is very interesting, in fact, I must say. So 10.2, there is something that I know, I remember from where we come from, right? Meaning we were able to prove triangle ABC was similar to triangle FBD. So let me do this. I do see an AD there, so we might need to do something. So I do see an AD there, and then I see an FB. So we need to be relating this. So I want to say, because I'm seeing an FB, I need something that relates with BF. Okay, or FB. I need a side that relates with FB. Okay, I need a side that relates with FB. Okay. So when I look at it, I'm like, okay, side that relates to it. I want to remind you, okay, let me use a different color. I want to remind you, triangle ABC is similar to triangle what? FDB, isn't it? Okay, cool. So this is just a reminder. Okay, this is just a reminder. Now I'm like, okay, how about I say AC? Okay, how about I say AC over BF? It's the same. Guys, you say AC or you say CA, it's the same. You say FB or you say BF, it's the same. Okay, so AC over, let me maybe write it as FB over FB. What is it equal to? I'm gonna try AB. Okay, I'm gonna try AB. Okay, I'm gonna try AB. AB over AB corresponds to what? To FD. Okay, it corresponds to FD. Why am I saying this? Because I said triangle ABC is similar to triangle F. Oops, is similar to triangle FDB. Okay, this is what I said. Now, I then want to think deep about this. So I'm like, AB. Okay, where's AB? AB. Okay, I see you. AB. A part of me says you are two times AB. A part of me says you are two times DB. Right? Hmm. Okay, but DB. I don't think I will be using DB here. I will be using AD. So therefore, I say, okay, AC over FB is equal to 2 times AD. And then we have FD. Where is it? FD. Who? We did say that E is the midpoint, right? We did say E is the midpoint. So if we said E is the midpoint, and I do see here we have EF, instead of using DE, I'm going to use EF. So FD, as you can see, it's 2 times this, 2 times DE or 2 times EF. So it's going to be 2 times EF, isn't it? In other words, AC over FB is equal to AD over EF. Now, this is very interesting. As I look here, I see an AC square. There is totally no AC cubed. There's totally no way that guys I can find this. Okay, there is totally no way that I can find this. But before then, I want to show you this. What if I were to say, no man, AC, you must be FB times AD over EF. Oh, wow. Do you guys see it here? I do see AD. Oh man, what is this? I do see AD times FB. Here is it, over EF. Okay, so this means on both sides, I must be dividing by what? I'm not sure, guys. On both sides, what must I be dividing with? A part of me says, let me divide by, or multiply by 1 over A squared. So 1 over AC squared multiplied by AC, okay, multiplied by AC, okay, is equal to, let's see, FB times AD all over EF multiplied by 1 over AC, what? AC squared. Oh, and then I do see AC squared. You are somewhere here. If we said this part here is 90 degrees, we are using Pythagoras, isn't it? We are using Pythagoras. But hold on. Pythagoras will work for this. But where do I get the cube from? Maybe I need to take this C to the other side as well. So let me leave it like this. A over AC squared equals FB times AD all over EF times AC cubed. Okay, guys, if you divide 3 out by AC, you will be getting AC cubed. Okay, now this question does not want you to simplify the left hand side, rather the right hand side. It wants you to simplify the right hand side. So I do recall that AC squared equals what? Equals AB squared. Hold on. Equals AB squared minus, okay, minus BC squared. Okay, this is what it means, and this is from Pythagoras theorem, right? So we can therefore say, okay, this therefore means we can say minus AC squared is BC squared minus AB squared. So check this out. It's minus, sorry, what is this? Because it's AC squared, let me just write it like that. It's AC squared, right? It's AC squared. Maybe let me substitute it like that. And then I'm gonna say, so we have 1 over BC squared, no, 1 over AB squared, hold on for now, 1 over AB squared, 1 over AB squared minus BC squared equals FD times AD all over EF times AC cubed. But there's a minus. Where is it coming from? Check this out. This is AB squared minus BC squared. So if you take a negative as a common factor, you will be having BC squared minus AB squared. Therefore, you can say it is equal to FD times AD all over EF times AC cubed. And this, ladies and gentlemen, is how you answer such questions. Okay, this is how you answer such questions. So we went ahead with like 2 minutes in actuality, but with regard to the exam, I think we were on time. We spent about 40 minutes. All right. So now we can say we have come to the end of our video. And remember, guys, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. And because you are watching on YouTube, please note the description to different social media platforms. Rather, the links to different social media platforms are given in the description of the video. So with that being said, ours ends here. And